Welcome. So what I'd like to do is show you how to graph an equation in slope-intercept form. So the first thing we need to understand is what exactly is slope-intercept form. Well, slope-intercept form is a representation of a linear equation in the form of y equals mx plus b, where b is going to represent our y-intercept. Now, our y-intercept is a point, so to represent that as a point, we'll do the 0, comma b, because it's going to be on the y-axis, so your x-coordinate is going to be 0, always 0. And m represents our slope. And slope is the best described as your change in the y-coordinates, or the change in the points on the line, the y-coordinates of the points, over the change in the x-coordinates. A lot of times also referred to as rise over run. All right, so how are we going to use the slope-intercept form to graph? Well, the y-intercept is pretty basic as it is. What we're going to do is on the y-axis, here's the x-axis, you're going to determine what the value of b is, and you're going to plot that on the line. So I'm going to do a couple examples for you. And let's graph here y equals negative 3/4 x minus 2, and y equals 5x plus 1. Okay? So if I was going to go ahead and graph this, I would go ahead and plot the y-intercept, which is at negative 2. So starting from the origin, I go down 2 units and I make a dot, which according as my y-intercept is 0, comma negative 2. That is a lot of times what we refer to as like our starting point for the line. If I was going to plot this here, my y-intercept is 1. So I'd go up 1 and make a nice dot, which is 0, comma 1. All right, so your y-intercept is always going to have an x-coordinate of 0, and it's always going to lie on the y-axis because it's the y-intercept. Where does the graph cross the y-axis? But the next thing, a little bit more difficult a lot of times for students to understand, is the slope. And that's going to be at the rate at which the line is either increasing or decreasing. So when we're looking at this, there's a couple different things that I want to kind of discuss about. And when we're going over slope, the best thing that I like to deal with slope is looking at the slope triangle. Let's pretend we have a triangle. All right, if we look at this triangle, you can see that from this point to this point, these points have changed certain directions. They've gone in the positive, right, direction, this amount, and they've also, which we'll like call x, and they've also gone up this amount, which we can call y. So this is what we call a slope triangle. And a lot of times when I'm first starting off, teaching slope, that's what I want students to be able to follow, is the slope triangle. Now, there is a little caveat to this that we need to make sure we're very clear on. So the slope we always want to represent as a fraction. Now, one important thing I want you to understand is a fraction for positive 2 over 1 is the same thing as negative 2 over negative 1. So that means instead of going up 2 or having a positive change and a positive change, we can also have a negative and a negative change. And the same thing goes with if I have negative 2 over 1, which is like the case over here, that's the same thing as negative 2 over 1, which is the same thing as positive 2 over negative 1. And I'll show you how that's going to work right here. So we have our y-intercept plotted. Now I have my slope, which is negative 3 over 4. And to graph this, I really just need to decide where do I want the negative sign to be. It doesn't matter if it's in the numerator or in the denominator, because all of these are going to equal negative 2. So I just need to choose. And for instance, let's just pick it being in the numerator. That means now from my y-intercept, I'm going to go down negative 3. Now the change in y is negative. Since it's negative, I go down 3 units. 1, 2, 3. Then, so that's going to be like the first part of my slope triangle. Now my 4 is positive, so that's going to take me 4 in the positive direction. 1, 2, 3, 4. So you can see what I have now done, let me rewrite this, is I've now created a slope triangle with my change in y over my change in x. And you might say, well, what happens when it's negative? Is that always going to be the same? Yes, of course it is. So to look at that, let's go and switch this, and let's make the 4 negative. Now my change in y is positive. So from my y-intercept, I'll go up 3, 1, 2, 3. And now I'm going to go to the left 4, because now the change in x is negative, so I'm going to go to the left. Negative 1, 2, 3, 4. So I went up 4, or up 3, and now I'm going left 4. And again, you can see that I've created a slope triangle, but if I was going to extend these, which a line extends, you can see that either way the slope triangle for the negative or the positive is always going to be exactly the same. For this one now, when you have a whole number, you can see, well, what is it? The change in y or the change in x? I don't have a y and x. I only have one number. So what I like to do when we have a whole number is rewrite this as 5 over 1. Because 5 divided by 1 is just 5. But now I'm rewriting it as a fraction so we can look at the change in y is 5 and the change in x is 3. Or is 1, I'm sorry. So here I can go up 5, 1, 2, 3, 4, 5, because that's positive. And that will be a positive 1 over here. So that would be my slope triangle. That's going to take me there, up. Now remember, as I mentioned over here, a positive divided by positive is the same as a negative divided by a negative. So now let's just try this as a negative 5 over negative 1, because I can also go in this direction. So I'd go down 5, 1, 2, 3, 4, 5, negative 1. And what you'll see is these graphs, if it doesn't matter which direction I go in, they have the same exact value. So just again to recap, just graph and slope-intercept form, plot your y-intercept on the y-axis, then apply slope to find your next point on the line. And there's infinite many points. You can do 2 to the right, 2 to the left, 1 to the right, 1 to the left, or just keep on continuing the slope forever because that's how long a line is going to extend with. So there you go, ladies and gentlemen. I hope that helped. Thanks.